Welcome to Astronomy Daily, your window to the universe where we bring you the freshest discoveries and developments from across the cosmos. I'm Anna, and I'm thrilled to guide you through today's fascinating journey through space. In today's episode, we'll explore a remarkable observation of a black hole violently expelling matter at incredible speeds into deep space. We'll also cover SpaceX's impressive launch milestones and the global surge in space activities happening around the world. Plus, we'll discuss the historic inauguration of the African Space Agency and what it means for the continent's space ambitions. And finally, we'll venture to our moon, where a massive ancient crater may hold secrets about our lunar companion's fiery birth. So settle in as we blast off into another edition of Astronomical Wonders and Cosmic Revelations. In a stunning discovery that challenges our understanding of these cosmic monsters, scientists have captured a black hole in the act of hurling matter into deep space at astonishing velocities. The culprit is located in NGC 4945, a beautiful spiral galaxy sitting over 12 million light-years away in the constellation Centaurus. While NGC 4945 might appear serene from a distance, it harbors a ferocious secret at its core. Unlike some black holes that quietly consume their cosmic meals, such as the relatively calm one at the center of our own Milky Way, this supermassive beast is both a voracious eater and a violent expeller. Using the advanced MUSE instrument on the European Southern Observatory's Very Large Telescope, astronomers have documented this black hole not only devouring surrounding material, but also generating powerful cone-shaped winds of gas and dust that blast outward with tremendous force. What's particularly fascinating is that these outflows, visible as striking red plumes against the galaxy's elegant spiral structure, are moving so rapidly that scientists expect them to completely escape the galaxy's gravitational pull. This matter will eventually drift into the vast emptiness of intergalactic space, a cosmic ejection on a truly enormous scale. This observation is reshaping our understanding of galactic dynamics. Black holes have long been known to pull matter inward with their immense gravity, but this dramatic example of matter ejection shows how these cosmic entities play a much more complex role in shaping their galactic neighborhoods. The expelled material, which would otherwise be available for star formation, is essentially being removed from the galaxy's inventory. This finding represents a pivotal moment in our quest to understand the intricate relationship between supermassive black holes and the evolution of their host galaxies across cosmic time. What makes this discovery truly revolutionary is that these black hole-driven winds behave in ways astronomers didn't anticipate. The MUSE data reveal something counterintuitive. Instead of gradually slowing down as they travel outward through the galaxy, these powerful outflows actually accelerate as they move away from the galactic center. They gain momentum on their journey toward the edge of the galaxy and eventually into intergalactic space. This acceleration mechanism is particularly significant for understanding galactic evolution. By forcefully ejecting potential star-forming material from the galaxy, these black holes effectively act as cosmic regulators, controlling the rate at which new stars can form within their host galaxies. It's a form of self-regulation that dampens stellar birth rates across the entire galactic structure. Even more fascinating is how this process creates a feedback loop that affects the black hole itself. By removing the very gas and dust they feed upon, more active and powerful black holes actually impede their own growth. This self-limiting behavior drives the whole system toward a kind of galactic equilibrium, a delicate balance between consumption and ejection. The new findings represent a significant step forward in our understanding of how galaxies evolve over cosmic time. These accelerating winds appear to be a key mechanism through which black holes shape not just their immediate surroundings, but the fate of entire galaxies. By regulating both star formation and their own feeding processes, these cosmic behemoths play a far more sophisticated role in universal dynamics than previously understood. Scientists believe that by studying these acceleration patterns in detail, we can better comprehend the forces that have shaped galactic evolution throughout the universe's history, one of the fundamental questions in modern astrophysics. Let's move on now and take a look at this week's launch schedule. SpaceX continues to push the boundaries of what's possible in the commercial space industry, setting remarkable records that would have seemed impossible just a few years ago. The company is on track to achieve its 250th mission launch from Space Launch Complex 40 in Florida this week, a milestone that highlights just how quickly SpaceX has transformed access to space. The pace of launches is nothing short of extraordinary. SpaceX has now surpassed 250 dedicated Starlink launches, rapidly expanding its satellite internet constellation to provide global coverage. Just last week, the company deployed a record 29 Starlink satellites in a single mission, demonstrating their ability to maximize payload capacity on their workhorse, Falcon 9 rocket. This achievement is particularly noteworthy because it also marked SpaceX's 50th mission of 2025, maintaining a launch cadence that averages nearly 3 launches per week. If this pace continues, the company is on track to potentially exceed 100 launches this year, a figure that the entire global launch industry struggled to achieve collectively just a decade ago. Perhaps equally impressive is SpaceX's growing mastery of reusability. The same mission marked the 100th consecutive successful Falcon 9 landing since their last landing failure. This perfect landing streak highlights the maturity of SpaceX's recovery technology and operations. The booster used for this mission, designated B-1078, became the 9th in the fleet to reach 20 flights, demonstrating the durability and reliability of these vehicles that were initially designed for just a handful of missions. The economics of this reusability revolution cannot be overstated. By recovering and refurbishing first-stage boosters, SpaceX has dramatically reduced launch costs while simultaneously increasing their launch capacity. What once required building dozens of new rockets annually can now be accomplished with a much smaller fleet of frequently flown vehicles. This unprecedented launch cadence is enabling SpaceX to deploy its Starlink constellation at a pace that competitors struggle to match. With each launch carrying dozens of satellites, the company is rapidly approaching the point where it can offer true global coverage for its internet service, including in remote and underserved regions where traditional internet infrastructure is impractical. While SpaceX dominates headlines with its impressive launch schedule, it's worth noting that they're not the only players in this increasingly busy orbital traffic pattern. Other spacefaring nations continue to maintain active launch schedules, with China being particularly noteworthy among them. In fact, China attempted to launch one of its Changzheng 12A rockets earlier this week, though the mission was scrubbed for reasons that haven't been officially disclosed. This particular rocket was set to carry the 4th batch of Xinguang satellites for the Guowang network, one of 2 mega constellations China is developing to compete with Starlink in the global satellite internet market. April 2025 has now secured its place in the record books as the busiest April in spaceflight history, with an impressive 26 rockets launching worldwide. This remarkable achievement reflects the growing commercialization and accessibility of space launch capabilities across multiple countries and private companies. Even more impressive was the flurry of activity that occurred at the end of the month. Between April 28th and 29th, a new global launch record was set when 6 different rockets blasted off within just 18 hours of each other. This unprecedented concentration of launches required careful coordination among various launch providers and space traffic management authorities to ensure safe operations. This accelerating pace of launches is expected to continue throughout May and beyond, with additional Starlink missions, crewed launches to space stations, and various satellite deployments already on the manifest. We're witnessing a historic transformation in how frequently humanity accesses space, and the trend shows no signs of slowing down. The space industry's rapid growth presents both opportunities and challenges. While increased launch cadence means more satellites for communications, Earth observation, and scientific research, it also creates concerns about orbital congestion and space debris management. International cooperation on space traffic management is becoming increasingly crucial as more rockets and satellites fill the skies. And another new player has just run onto the playing field. On April 20th, 2025, a significant milestone in African space exploration was achieved with the formal inauguration of the African Space Agency, or AFSA, in Cairo, Egypt. This development marks nearly a decade of coordinated planning since 2016, when the African Union first adopted the Comprehensive African Space Policy and Strategy Framework. The creation of AFSA represents a deliberate move to unite the continent's space ambitions under a single organizational umbrella. Currently, 22 African nations operate their own space agencies, with varying degrees of legislative support and organizational structures. Some are fully independent agencies backed by national legislation, while others function as departments within broader research institutions. This new continental agency will serve as the coordinating body for Africa's existing space programs, streamlining cooperation between member states and creating a unified voice when engaging with international partners. Rather than replacing national agencies, AFSA will amplify their collective impact through strategic coordination. The agency's mandate includes establishing a centralized point of contact for negotiations with private launch providers, satellite manufacturers, and other space services companies. This unified approach gives African nations significantly more leverage in these discussions than they would have individually. Dr. Tidiane Ouattara, president of the AFSA Council, emphasized at the launch ceremony that the agency will focus on practical applications that benefit African citizens, including improved agricultural forecasting, disaster monitoring, telecommunications infrastructure, and educational opportunities. Many African space agencies already specialize in Earth observation missions, tracking climate patterns crucial for agriculture, and providing services like navigation systems and emergency response coordination. The South African National Space Agency, for example, has developed a successful satellite-based wildfire detection system that identifies remote blazes and alerts firefighting authorities. Through AFSA, these specialized capabilities can now be shared more effectively across borders, creating a multiplier effect that benefits all member states while avoiding costly duplication of efforts. The agency will also play a crucial role in standardizing regulations, protocols, and technological systems across the continent's space sector. Despite Africa's vast geographical footprint covering 1/5 of Earth's land surface, the continent currently contributes a mere 0.5% to the global space budget. This stark disparity highlights the significant untapped potential within Africa's space sector. The newly established African Space Agency aims to fundamentally transform this reality, pivoting the continent from being primarily a consumer of space technology and data to becoming an active producer and innovator. As Dr. Ouattara aptly described it, Africa is a sleeping giant in the space economy. With ambitious projections estimating space economy revenue reaching $22 billion by 2026, the agency recognizes that current activities have only scratched the surface of what's possible. The focus now is on leveraging Africa's abundant natural resources, alongside its growing pool of engineering talent, to develop indigenous space capabilities, rather than relying on imported solutions. Three key pillars form the foundation of AFSA's approach: recognizing the necessity of space technologies for development, establishing robust structural frameworks to support growth, and positioning Africa advantageously within the emerging landscapes of new space and artificial intelligence. Infrastructure development stands as a critical priority, with plans to both incorporate existing facilities and construct new ones across member states. This doesn't solely involve physical launch sites and satellite manufacturing capabilities, but also encompasses developing specialized educational programs and training opportunities to build a skilled workforce. The agency will emphasize educational initiatives at all levels, from primary school programs that spark interest in space sciences to advanced university curricula that produce the next generation of African aerospace engineers, astrophysicists, and mission specialists. Creating this human capital pipeline is considered essential for sustainable growth in the sector. Resource coordination represents another major focus area. Given the substantial investment required for space programs, AFSA will facilitate resource sharing among member states, preventing costly duplication of efforts while maximizing the impact of available funding. This cooperative approach extends to sharing markets, technologies, and scientific outcomes. Through these coordinated efforts, Africa aims to claim its rightful place in the global space community, transforming from a minor player to a significant contributor in international space exploration and utilization. Let's change gears now. Approximately 4.3 billion years ago, a massive celestial body slammed into the lunar surface, creating what we now know as the South Pole Aitken Basin. This colossal impact crater, spanning a significant portion of the moon's far side, may hold secrets that could revolutionize our understanding of lunar formation. Recent research suggests this basin contains pristine fragments of the moon's mantle and remnants of an ancient magma ocean dating back to when our lunar companion was still cooling and solidifying after its violent birth. These materials offer a rare geological time capsule, preserving evidence from the final stages of the moon's formation process. What makes this discovery particularly intriguing is how it challenges previous scientific assumptions. Researchers studying the basin's distinctive teardrop shape have determined that the massive impactor was actually moving southward when it struck the lunar surface, not northward as previously thought. As planetary scientist Jeff Andrews Hanna from the University of Arizona noted, "We have had the data we needed to measure the shape of the basin for a long time. It just took a different perspective to view the basin this way." The impact was so powerful that it appears to have punctured through the lunar crust, allowing material from the still crystallizing magma ocean beneath to seep upward. This explains the presence of thorium and other distinctive elements consistent with creep materials, potassium, rare earth elements, and phosphorus found across the basin floor. This excavation provides a unique window into the moon's interior during a critical period of its evolution. When the moon first formed from debris following a collision between Earth and a Mars-sized object, both bodies were briefly liquefied. As the moon cooled, low-density minerals floated upward to form the crust, while denser materials sank inward, creating the distinct layers we observe today. The South Pole Aitken Basin effectively captured a snapshot of this process in action, preserving evidence of the magma ocean's composition at a specific moment in lunar history. By analyzing these materials, scientists hope to refine our timeline of exactly when and how Earth's companion took shape. The upcoming Artemis missions represent a once-in-a-generation opportunity to answer fundamental questions about lunar formation. When astronauts return to the moon in 2026, they'll be able to collect and bring back samples from the South Pole Aitken Basin, giving scientists direct access to materials from the moon's ancient mantle. These samples are particularly valuable because they can be compared with materials already in our possession. During the Apollo missions of the 1960s and 70s, astronauts returned with rocks from the Procellarum creep terrain, another region rich in those distinctive potassium, rare earth elements, and phosphorus materials. More recently, China's Chang'e 5 mission in 2020 and Chang'e 6 in 2024 have added to our collection of lunar samples, with the latter specifically returning materials from the South Pole Aitken Basin. What makes this scientific opportunity so compelling is that these different areas represent distinct snapshots in time. By analyzing materials from both regions, scientists can observe how the lunar magma ocean evolved during different periods. It's like having photographs of a developing child taken years apart. The differences tell a story of growth and change. Andrews Hanna emphasized that this research is about more than just understanding the moon. The magma ocean is inextricably tied to the birth of Earth, he explained. While scientists have general timelines for how long it took the lunar magma ocean to crystallize, precise dating remains challenging. Once Artemis astronauts return with these samples, laboratory analysis can determine a precise age for the South Pole Aitken Basin, which will provide an exact timeline for the late-stage magma ocean crystallization. This data will help scientists refine models of how both the moon and Earth formed and evolved in their earliest days. The comparison between the South Pole Aitken Basin and the Procellarum creep terrain holds additional significance because previous theories suggested the massive impact that created the basin might have pushed magma ocean material to the opposite side of the moon, forming the Procellarum region. New evidence indicates these areas formed independently, with the South Pole Aitken impact occurring earlier in lunar history. And with that, we wrap up our cosmic journey for today. From black holes hurling matter into deep space to new revelations about the moon's ancient magma oceans, we've traveled across our solar system and beyond. The universe continues to reveal its secrets to those patient enough to look and listen. As we observe Africa taking bold new steps into the space arena and anticipate what Artemis astronauts might discover on the lunar surface, it's clear that space exploration remains one of humanity's greatest adventures. I'm Anna, and I want to thank you for spending this time exploring the cosmos with me. If you enjoyed today's episode, please visit our website at astronomydaily.io, where you can sign up for our free daily newsletter and access our complete archive of past episodes. Connect with us on social media too. You'll find Astro Daily Pod on Facebook, X, YouTube Music, Instagram, Tumblr, and TikTok. Your support helps us continue bringing these fascinating stories of space and astronomy to listeners around the world. Until our next journey together through the stars, keep looking up.